Let me first thank my students for sharing their test papers and examples so that we can actually bring the best for you. Let's enjoy this journey of learning. Welcome to our series on calculus. In this video, we are going to take 5 questions which are based on tangents to a curve. We are going to use power rule for derivatives. It is Unit 2 for calculus. Let me thank all the viewers and subscribers for watching my videos, posting excellent comments, and sharing their test problems. Now, this set comes from my student who wants to understand how do we find gradient or slope at a particular point on the curve and also equation of tangent line. So we'll take up 5 examples from his notes to work it out. And I hope it is going to help many others. Now, as the remarks says, gradient of the curve is also gradient of the tangent at the curve at that point. So this is important to understand. And here we have the very first example which says find the gradient of the tangent to the curve whose equation is y equals to 4 over x plus 2 at the point where x equals to 2. So it's a reciprocal function. Let us rewrite the function here, which is y equals to 4 over x plus 2. Now, many of my students will like to rewrite this in this form, x to the power of minus 1 plus 2. The reason they're just learning the power rule, right? So let me rewrite the power rule here, which is if we have y equals to a times x to the power of n, in that case, differentiate with respect to x, that this derivative will be written as n times a times x to the power of n minus 1. So it becomes easier for them to write this minus 1. That is why in this video, I'm going to use this nomenclature. So let's find the derivative with respect to x. So dy dx. So we say derivative with respect to the variable x, right? Will be applying the power rule minus 1 times 4. So I get minus 4 x to the power of minus 1 minus 1, which gives me minus 2. Now plus 2, it is a constant, its derivative is 0. So we need not even write, right? If you want, you can, but we are going to avoid it from hereafter. So dy dx, now we found the derivative as equal to, is good to write it in normal way, which is minus 4 over x square. Makes sense? So we have found the derivative. But the question here is, find the gradient. Derivative gives you the gradient of tangent to this curve, but we have to find it at x equals to 2. So let's do the second part now, which is gradient at x equals to 2. So the nomenclature is to write it like dy dx, differentiate with respect to x, and find the derivative at x equals to 2. So now you substitute 2 in the equation, which is minus 4 over 2 square, right? Which is equal to minus 4 over 4 or minus 1. So the derivative is minus 1, okay? So dy dx at x equals to 2 is indeed equal to minus 1. Is that clear to you? These are the simplest steps to find the derivative at a given point on the curve of the tangent. Perfect. Now let's look into second example, which is very similar. So I'd like you to now pause the video, answer this question, and then look into my suggestions, right? Those of you who want to learn directly from me, feel free to send an email on globalmathinstitute at gmail.com. Our students are right there on the top since they have excellent concepts. So let's continue with our solution. We know y is equal to 5x cubed minus 2x squared minus 4. The question is, the equation of the curve is given. Find x coordinate of the point where the gradient is 5. Slightly different, right? We are given the gradient, right? In this case, y prime is given to us, right? But we want to find this value of x where the gradient is 5. Do you understand the question? So that is how this question is very different from the last question. Makes sense, right? Beautiful set of examples. Now let's continue. So derivative, which I can also write as y prime, so differentiate with respect to x, gives us 15 x squared minus 4x, right? That is 0. So we have again applied the power rule, right? Multiplying with the index, the power, and decreasing the power by 1. Now what we are given is that this is equal to 5. So we want to find that value where all this is equal to what? 5, right? So let's rewrite this as equal to 5. So we have to solve this equation now, right? We can bring all the terms to the left hand side. So we get 15x squared minus 4x minus 5 equals to 0. So we want the point where the gradient is 5. So you have this particular quadratic equation. Now at this stage, you can do a couple of things. One, you could factor using product and sum formula, right? We need product of two numbers whose product is 15 times minus 5, correct? So let's do that and then find what those numbers could be. So let us do it here. We want product to be minus 5 times 15, correct? Two numbers whose sum is minus 4. So we could split this as 3 and 5, correct? And then we can see if there is a combination with which we could work, right? Because we got only these three numbers to work with. So minus 4 you can get not with these combinations, right? So in that case, what we are going to do here is going to use a quadratic formula, correct? So the quadratic formula, as you know, that the value of x is equal to minus b plus minus square root of b square minus 4ac divided by 2a, right? So in this case, the value of x will be minus b, means minus of minus 4, which gives us 4, plus minus square root of b square 16 minus 4 times a is 15 times minus 5, correct? Over 2 times 15. And that gives us 4 plus minus square root of 16 plus. That minus becomes plus, right? So 20 times 5 times 5, 4 is 20 times 15 becomes 300 over 30, correct? So now we can use the calculator to find the answer, right? After you, this is like 316, right? So you can say 4 is common. So you get here equals to 4 plus minus 2 times square root of 79, right? Over 30. You can simplify this value of x and rewrite this as 2 plus minus square root of 79 over 15, right? So there are two values of x, right? Just find the x coordinate. So there are two values of x at which the gradient is 5. Does it make sense to you, right? So our answer is this, right? So x is equal to 2 plus minus square root of 79 divided by 15, right? So because we could not factor it, we use quadratic formula to find the answer. I hope it makes sense. Perfect. So I hope this is also absolutely clear. Now let's move forward and take up the next example, which is Find equation of tangent to f of x equals to x square plus 1 at a point where x is 1. So this time we are finding equation of tangent, right? So for equation of tangent, we have to first find the derivative. So we are given the function f of x as equal to x square plus 1. Derivative of this function is equal to 2x. We are interested at point x equals to 1, right? So we'll find the derivative at 1, which is 2 times 1 or 2. We have also to find the value of function at 1, so it is 1 square plus 1, which is also 2, correct? So basically, we know now that the slope m is 2 and the point P is also 1 comma 2, right? 1 is the x value, y value is 2. Once we know that, we can write down the equation of the line. Now, some of you will like to write down the equation slope intercept form. Let's do that. So y equals to mx plus b. So in this case, we know that the slope is 2, so it is 2x plus b. To find the value of b, we are going to use the point 1, 2, right? So y value being 2, so 2 times 1 plus b. So 2 minus 2 equals to b, which is 0. And therefore, we get the equation of line as y equals to the slope 2x. So that becomes the slope of the line y equals to equation of the tangent line. So this is equation of tangent line, right? So equation of tangent line is y equals to 2x. Makes sense, correct? So as you can see, this is a parabola which if you sketch will be vertically upright. I'm just making a rough sketch here. And it seems that the tangent goes through the origin. Is that clear to you? And this is the point which is 1, 2. Makes sense? So that becomes the equation of this line. And you can see how it really works out. Perfect. So I think you have also understood how do we find equation of a tangent line. Perfect. So these are the type of questions which you normally get. Now here is another question based on what we learned so far. I would like you to now pause the video, answer this question, and then check with my solution, right? So you need to consolidate on the learnings. That is the key. Question here is find the coordinates of any point on the curve with this equation where tangent is horizontal. So let's rewrite the equation, which is f of x equals to x cubed plus 3x squared. Now, what does it mean when we say tangent is horizontal? It really means that the slope m or f prime x is 0, right? Horizontal tangent. So these are the turning points on the curve. Okay, so these are the turning points. Visualize as you move forward. It always helps, right? Now let's find the derivative of this particular function, which is 3x squared plus 6x minus 9. You should factor this, right? So if I factor, I can take 3 common, right? So we get x squared plus 2x minus 3, which is 3 times. Minus 3 means 3 times 1, so 3 is positive. Correct. So now we got the points. Now we want this derivative to be 0. That means 3 times x plus 3 times x minus 1 should be equal to 0. This is what we want. And that gives us different values of x. One will be x equals to minus 3. The other one is plus 1. So these two values will give us horizontal tangent. But what do we need? We need to find coordinates of any points. Coordinates mean both x and y values, correct? So now let's find the y value also. So for x equals to minus 3, let us substitute x as 1. first we'll find 1. Okay, let's do that. So when I plug in 1, I get 1 plus 3 minus 9 plus 5, which is equal to 1 plus 3 is 4, 4 plus 5 is 9, and that is 0. And therefore, the coordinate point is 1, 0. Okay. The next point is minus 3, correct? So let's substitute minus 3. So minus 3 cube plus 3 times minus 3 square minus 3 times minus 3 plus 5, correct? Which is minus 27. So 9 times 3 is plus 27. Minus and minus becomes plus. 9 times 3 is again 27, correct? So, and we have plus 5, correct? So we get a point. 27 minus 27 cancel, 32, correct? And therefore, we get the second point, which is, so we can write down the points now, correct? So one is at minus 3, the y value is 32. The second one is at 1, the y value is 0. So these are the 2 points at which we have a horizontal tangent. Makes sense, right? Great. So I hope you are enjoying this journey of learning. Let's take one more question. The question here is, find the equations of any horizontal tangent to the curve, right? Similar to the last one, but this time instead of just finding a point, we need to find the equations, right? So there could be more than one. So remember that part. Let's rewrite the equation and solve. So we have y equals to x cube minus 12x plus 2. So derivative y prime is 3x squared minus 12. So we want horizontal tangents, means this should be equal to 0. Okay. So 3x squared equals to 12. X squared equals to 12 by 3, which is 4. So x is equal to square root of 4. Whenever you do square root, you have to do plus and minus. So you get x equals to plus and minus 2. Makes sense? So there are 2 points where we have a horizontal tangent. So we are going to work on both the points, correct? One at x equals to minus 2, the other one at x equals to plus 2. So let's find the y value at each, right? So if I plug in minus 2 here, I get minus 2 cube minus 12 times minus 2 plus 2. And plugging it here, you can do the calculations, right? Plus 2. So let's find the y value, which is minus 8, and this is plus 24 plus 2, right? So minus 8 plus 24, that means from 26 we'll take out 8, which is 16. 18, right? Okay. So that is the first one. We get 18. So we have a point which is, you can write the point, let's call this point as A, being minus 2, 18, correct? Now let's find the other point. So y equals to 8 minus 24 plus 2, which is 10 minus 24 or minus 14, correct? So the other point B is at 2, we have minus 14. Makes sense? This is a cubic equation. We got these 2 points where we have horizontal tangent, right? So that makes sense. So basically, you can visualize this cubic equation as a graph, which could be, let me just sketch a graph here, right? Something like this. Is it okay? So we have 2 horizontal tangents, one right there and one here, correct? Those are the 2 points, A and B, which we are calling. Is that clear to you? Make sense? Let's find this equation. Horizontal means the y values, right? So the equation of tangents at A will be y equals to the y value, which is 18, and at B it will be y equals to minus 14. You see that? So that is how we are going to find the solution of this particular equation. So we found the equation of horizontal tangent lines for the given cubic equation, as you have seen here. So I hope it all makes sense, right? So with this, you'll learn the techniques to find the gradient or the slope at any point on the curve. You have also learned how do we find a point for the given gradient, and then how do we figure out where will there be a horizontal tangent, and also the equation for the horizontal tangent. With these five examples, we have a good insight to the curves and the tangents on these curves. Using power rule, we have done all these questions. Hope it makes sense. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.